This thing shoots fast, but I apparently don't know how to aim. To fix that, I turned it into a self-aiming turret. Okay, I lied. I haven't turned it into a turret yet, but I did build this dart loader for it. Loose darts go in here, some magic happens, and a 50 dart magazine comes out the other end. Before I show you how this thing works, I'm going to show you some previous projects first. This turret is the first project I made for this channel, and this sad looking heap of parts was version 2. Both aim and fire standard size Nerf darts, which is cool but not very unique. What really sets these apart is the fact that they automatically load their own darts. My plan is to take these turrets to the extreme using this terrifying contraption. Normally, I'd start by making it into a turret, but I was going to show this thing off at open source. To avoid the painful 5-minute loading process every time I fired it, I decided to design a dart loader first. The first step is to figure out how to quickly sort and organize these loose darts into some sort of magazine. Right off the bat, I noticed how most of the darts naturally settled nose down. If we focus on one dart, it's pretty obvious why. The center of gravity for these is so far forward that their most stable positions are either standing up or really close to it. I wondered what it would take to get these standing up, so I swept them into a box and gave them a shape. Conveniently, it didn't take long before nearly every dart was nose down. This was enough information to start prototyping, so I made this box. Darts will fall through these holes and be kept in line with these slats. The whole thing is hot glued to a linear rail, so it can shake back and forth. As I shake the box, the darts start standing up and fall through the holes nose down. And after enough time, they all eventually fall out. I cleaned the design up a bit and added a hand crank for the dart hopper. This section down here is similar to the first one, but with flexible walls made from cardstock. These connect the moving hopper to a stationary portion that a magazine will eventually attach to. Its first test went pretty well. I then made this gate from cut up pieces of tape measure. This will keep the darts in place when I remove the magazine. I then added this dual-purpose lever that will open the gate and simultaneously latch the magazine in place. The last thing I made was this very simple magazine. I put everything together and tested it. As you can see, the darts get caught in a lot of places. The most obvious jams happen in this section. Each of these cardstock dividers should be parallel, but since they're not, the darts can double up and jam. Right now, each end of the cardstock is glued in place. When the hopper moves to either side, the cardstock is tight, but in the middle, it has to bend. This bending can allow the cardstock to create very wide or very narrow channels. To fix this, I kept one end glued and put the other end in this little slot. This should allow each divider to remain parallel without any bending. I built some new sorter parts, made some other minor adjustments, and did some more testing. Sorting went better, but these flimsy cardstock dividers were still causing issues. The cardstock isn't rigid enough to stay straight, so I'm going to replace them with these 3D printed dividers. These new dividers are still flexible enough to move, but rigid enough to stay relatively straight. The last issue the sorter had was a bit harder to see. When the gate was open, it left a large gap for darts to get stuck. I redesigned the gate and made some new parts. The result is this thing, and it works flawlessly. All of these dividers stay parallel, darts don't get caught anywhere, and the magazine gets filled up quickly. Now that I have 50 perfectly sorted darts, I can easily load them into the barrel of this blaster. Wait, Give me a second. This indexer should make things easier. It installs on the front of the blaster and the magazine goes onto its carriage. Turning this crank will index and line up each magazine chamber with the barrel. This crank turns this bevel gear, which then turns this drive wheel. The drive wheel has a steel pin that advances the carriage one step at a time. This type of mechanism is called a linear Geneva drive. With the indexer, I can push in a line of darts, turn the crank, and then push in the next line. Once the last line of darts has been pushed in, I use this thing to push the darts in the rest of the way. And just like that, the blaster is ready to fire for open sauce. Open sauce was super cool and I had a lot of fun. We probably shot this dart blaster a couple hundred times and it only jammed a handful of times. The loading process worked very well, but there were so many steps involved that mistakes were prone to happen. So the next logical step is to automate the entire process. But before we get into that, let's hear from the sponsor of today's video, Aura.
In today's age, data leaks are an all too common occurrence. In fact, Ticketmaster was recently hacked and the data for over 560 million users was put up for sale on the dark web. This includes full names, addresses, email addresses, phone numbers, and credit card data. So what did Ticketmaster do about this leak? Nothing. They didn't think the leak had a material impact on their overall business. So what can you do to protect your data? Well, you can either completely go off-grid and live in the woods like Malachi here, or you can use Aura, the sponsor of today's video. Aura will alert you when your data has been part of a data breach or leaked on the dark web. It gives fast fraud alerts if anyone tries to use that data to access your credit or bank accounts. Aura will also remove your data from data broker websites so you get less spam. You can also get things like transaction monitoring, a VPN, antivirus, a password manager, parental controls, and identity theft insurance. You get this all in one app at one affordable price. If you want to protect your data and your peace of mind, you can go to aura.com/projectbox and get your first 2 weeks free. Link in the description. Is that good?
Yeah, it was great.
Sweet. Malachi! You can go back now!
Dude, I don't see him. What the crap was that?
Oh, wait, Malachi! Aura can protect your data!
Really?
Yeah.
Sick.
Sweet. Whew. Let's get back to sorting darts or whatever.
Yeah, that sounds good to me, man.
This loading system has three main parts: the dart sorter, magazine, and the magazine indexer. Each part needs to be automated in a way that will allow them all to work together. Let's look at the process again and make note of what needs to change. This hand crank will need to be replaced with a motor, which will be very easy. To know when to stop the hopper motor, IR sensors can be placed in each of these channels. Releasing the magazine and closing the gate can be done with a servo. The transfer between the sorter and the dart indexer can be replaced with a... I'll just show you in a second. And finally, to replace this pushing motion, each pusher will be spring-loaded with individual releases. There are some other things I'm going to add, but I'll just cover those later. I went to work designing, and after dozens of hours, I came up with this beautiful thing. The sorter has a motor, a servo-actuated gate, and a bunch of IR sensors. This crazy looking contraption down here is used to grab the magazine and move it to and fro. The magazine is quite a bit more complicated than before, but don't worry, I'll explain it in a bit. And now that the design was complete, I made a few parts. Actually, I made a ton of parts. This is gonna take a while. 4.5 hours later, it's finally finished. But before diving into the details, let's do a quick tour. Up top is the new sorter, and down here is the magazine gripper. To the left is a storage rack for extra magazines. On the back underneath this rat's nest are most of the electronics. There's a lot to each of these sections, so let's break it down starting with the electronics. Despite the mess, the electronics aren't too crazy. AC power goes into this 12-volt voltage converter. 12 volts is then fed into these two DC motor controllers and these three DC converters. These motor controllers are for the sorter motor and a motor on the magazine gripper that I'll explain later. These two DC converters step the 12 volts down into 3 volts for these stepper motor drivers. This last DC converter outputs 5 volts for this Arduino Mega and various servos. Let's look at the sorter next. There's nothing too special about this version of the sorter. The gate servo works, the motor works, and it sorts darts. What doesn't work right now are the chamber sensors, but that's because I haven't installed the IR LEDs or receivers yet. I'll add those in later when I get the rest of the system working. Up next, the magazine. This magazine is pretty complicated, so let's start by looking at the cardboard one. The pushers in this magazine worked well enough, but they tended to rotate in the channel and get stuck. To fix this, I printed a single channel with 2 guide rods to keep the pusher straight. For the spring, I decided to reuse the design of this previous dart loader I made for my second Nerf turret. Essentially, it uses a spring-loaded string that winds through a set of pulleys. Instead of doing a custom spring again, I bought a bunch of these ID badge reels. I installed the spring and it worked very well. For the second prototype, I split everything into different layers instead of doing one large print. This way, if I need to change anything, I don't have to reprint the entire magazine. These middle layers are basically just spacers, so I laser cut them from acrylic to save printer time. Of course, I didn't really save much time since each of these small slices took 3 minutes to cut. On top of that, I had to keep pausing my laser to prevent it from overheating. I'll be printing the full thing later. Anyway, let's look at how I'm going to retract each pusher. If this looks familiar, it's because I reused the design from this dart loader again. This retract mechanism uses a driving wheel and a spool of fishing line. To retract, the spool is pushed into the driving wheel, which will spool up the fishing line. To release, the spool is pulled away from the driving wheel, allowing the spool to unwind and release the pusher. This design works great for this loader, but I need 10 of these spools in a row. Having individual pusher motors for each spool just won't work. For the new design, I got rid of the pusher motor, replaced the motor shaft with a Lego axle, and added 9 extra sets of slightly larger spools. Each of these drive wheels are fixed to the drive shaft, and each of these spools spin freely around it. This motor is way too small to turn all 10 spools, so I replaced it with a much larger one. I also separated the motor from the shaft with a drive wheel setup similar to the spools. This way, I don't have to attach a motor to each magazine. The final piece of the puzzle is how to move the spools. To do that, I added a 2-piece ramp thing. This ramp moves in and out, which forces this other ramp to push the spool into the drive wheel. A spring will be added here to make sure the spool separates from the drive wheel. And now each spool can independently be moved and released. In practice, the design works pretty well. I just push these ramps to mesh the spools together, and then I can spin the shared axle to pull down both pushers. Releasing them is just as easy. When I wind up the spools, I have to keep pressure on the axle to keep it from free spinning and unwinding. On this last loader, the motor held it in place. Since the motor is no longer permanently attached, I needed a different solution. To fix it, I printed this ratchet and pawl. These allow rotation in one direction but not the other. I hot glued it on and it worked great. One problem I had were these ramps. When I turn the axle, this one likes to drift and release the spool early. These ramps can be in any number of positions along these guide shafts, but there's no need for these to be anywhere in the middle. To fix this, I added a leaf spring and put a nub on the ramp. When the ramp is at either end, the spring is in a relaxed state. Anytime I start pushing the ramp to the other side, the spring pushes back and tries to keep the ramp in place. With enough force, the ramp can move over to the other side, where it's kept in place with the spring again. This means that the ramp has only two stable positions, making this a bistable mechanism. Fun fact, switches like these use the exact same principle. I of course didn't test this on the scale model and just went ahead and printed out the full scale magazine. I hope it works. The full scale version has 10 chambers, 10 springs, and 10 retract spools. On either end of the axle, I added a ratchet and pawl. The plastic Lego axle just wasn't going to cut it, so it was replaced with an aluminum one. I pushed all the spools together and gave the axle a spin. It started off well, but then I heard some slipping. I kept going, but in the end, only 3 of the pushers actually retracted. Bummer. For some reason, I only figured out why this happened when I was editing this portion of the video. At the time, I thought the spools weren't meshing far enough together, but it turns out the ramp would drift just far enough to release the spool. The spring I have in here isn't strong enough to keep the ramp all the way to the end, so fixing it should be as simple as beefing up the spring. Of course I didn't realize this at the time and had already decided to move on. The gantry can be split into 2 main parts, a simple XY gantry and a complicated gripper. The XY gantry uses the couple basic stepper motors that I stole from a 3D printer that I no longer needed. These are weird ones that run on 3 volts, so I'm driving them with these special low voltage stepper drivers from Pololu. To home itself, each axis has 2 limit switches at each end. It's really nothing special. The gripper, however, has quite a lot going on. It needs to perform 3 tasks: gripping the magazine, individually releasing each channel of the magazine, and spinning the axle to pull the dart pushers down. To grip the magazine, I decided to use parallel grippers. These have 2 fingers that are mechanically synchronized with the rack and pinion. Each gripper has an extra gear rack on the bottom that will interface with these gears. Once the grippers are installed, this drive shaft will move both grippers. I put the gripper pins in the magazine holes, closed the grippers, and gave the whole thing a nice shake. It holds pretty darn well considering most of this is plastic. With the gripper working, I then had to figure out how to individually move all 10 of these ramps. I tried to cram 10 servos in this small space, but it just wasn't going to work. Instead, I built this thing. Using only 4 servos, it has the ability to manipulate all 10 magazine ramps. This ramp selector assembly isn't too complicated. Each of these red selectors have 5 nubs that are spaced so that only one is ever in line with a magazine ramp. To move one of the ramps, one selector moves to be in line with a ramp and the other moves out of the way. Once in line, these other 2 servos on the bottom move both selectors forwards or backwards. All the servos move as expected, so it looks like this thing will work. I'll test it with the magazine in a bit. The last part of this gripper are these parts here. It's got the servo that will drive the grippers, the motor that will turn the magazine's axle, and this 16-channel I2C servo driver. All 5 servos will plug into this, so I only have to route a couple of wires back to the Arduino. Now that we've covered everything, let's get to testing. The first thing I did was write a simple program to test each part of the system without the magazine. The program starts with homing the gantry. Once homed, it'll pick up a magazine and retract all of its pushers. The magazine will then be taken to the sorter to get filled with darts. The magazine is then taken to the storage rack, and then immediately taken to where the turret will eventually be. At the turret, each chamber of the magazine will be sequentially released, loading all of the darts into the blaster. Now that I knew all the components worked, I decided to do a manual test run with the magazine. And in a not so shocking turn of events, my design immediately started having problems. When I closed the grippers, the far gripper didn't close all the way, which let the end of the magazine wobble. This was caused by some backlash with the far gripper. On the near gripper, the rack and pinion moved completely together. On the far gripper, the rack and pinion had a noticeable amount of backlash. I just manually closed the far gripper all the way and moved on to testing the retract motor. Naturally, the retract motor also had some issues. When turning the motor, the tool wheels would separate and skip teeth. Since these teeth mesh together at an angle, the rotation of the motor is pushing these wheels apart. If I force the two halves together, the motor rotates the axle just fine. Changing the geometry of these teeth should fix this pretty easily. I tested the selector next by having the program move each of the 10 ramps forwards and backwards. The selector didn't quite reach the ramps on the ends, but that should be easy enough to fix with some adjusting. Next I had the selector arm a single chamber, and then I had the motor retract the pusher. Once fully retracted, the selector released the chamber exactly as intended. Nice. I then armed the rest of the chambers and tried to retract them all. Unsurprisingly, it didn't work. The ramps were still drifting and letting the spools separate. Things weren't off to a great start, so I moved on to something that should be hard to mess up, the magazine rack. Naturally, the holes didn't line up because the rods were slightly bent. I was able to bend the rods a bit and the magazine slid onto the rack. I released the gripper and the whole thing immediately sagged. This thing moves way too much. But I guess I shouldn't be too surprised though. This magazine is a hefty 2.76 pounds resting on these tiny 3mm rods. Okay, let's try out the sorter. Surely that will be the one thing that actually works, right? I undid all the magazine springs, pushed down all the dart pushers, and then took it to the sorter. The sorter mostly worked, but this one channel just refused to fill up. Eventually, I had to move darts around in the hopper, and the magazine finally filled up. I tried to pull the magazine away, but the darts were sticking out just far enough to keep it in place. To get it out, I had to push all of the darts back up into the sorter like I was picking some sort of lock. And would you look at that, a magazine full of 50 darts.
Alright, things may not have gone according to plan, but at least all these issues should be fixable. To summarize, the dart pushers in the magazine release early, the magazine gripper doesn't close all the way, the retract motor slips, the selectors can't reach the first or last ramps on the magazine, the magazine rack moves way too much, and darts from the sorter trap the magazine in place. That may sound like a lot, but I mostly know how I'm going to fix all those issues. I would have fixed them all for this video, but I may or may not have committed to a certain release date for it. Whoops. Anyway, if you made it this far into the video, thanks for watching. If you want to get project updates and see behind the scenes videos, join my Patreon, link in the description. Alright, see you in the next one.